Hello, and what I'd like to do today is talk about galaxies. I'm going to call this Galaxy 1, probably Galaxy 1 of 2. This one I'm just going to talk about basic galaxies, what they represent, where they're located, how far away they are, how densely they're populated. I'm also going to talk about intergalactic space, space in between galaxies. You can also have interstellar space, spaces in between stars of a galaxy. You can have interplanetary space, spaces in between planets in a solar system. But today we're going to talk about intergalactic of those three. This is a deep field view from Hubble, and what you're looking at, if you actually take a look at these circles are stars in between the Milky Way galaxy, our galaxy, and everything else you see that's not circled. Like, that's a galaxy, that's a galaxy, there's a galaxy, 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 galaxy. You can just see probably thousands of galaxies in this picture. What does this represent in the sky? If you held out a human hair at arm's length and actually made a square out of that human hair, in other words, you take that human hair that looks like this, and you actually take the width of a human hair, which may be 100 angstroms, and you actually take that square out of there. This is about the size of this picture. So it's not very much of the sky. So if you could actually look at the sky, you can actually see why we say that there are really hundreds of billions of galaxies that are out there. Okay, so let's talk about this galaxy right here. This galaxy actually represents probably, let's say, a nice 100 billion stars, very similar to the Milky Way galaxy. Traveling from one side of this galaxy to the other side of this galaxy would take you about 100,000 light years. Remember, a light year is the distance light travels in 1 year. It's about 6 trillion miles for each one of those 100,000. So if you could actually take a laser and shine it in towards the middle of this galaxy, it would make it all the way across the other side in 100,000 years. So if we actually started in 2012, we'd have to add 100,000 to that, and we would see that light. If we were located on the other side that somebody else shown, we'd see it at 210201. We'd see it in the year 102,012. Long way away. Okay, so if you talk about regular galaxies, the inside of this galaxy is pretty densely populated. Stars can be I don't know, probably, well, let me give you where we're located. We're located about 2/3 of the way out, and if I was going to show you the density of stars, if I over here drew a Washington Monument, because we're located pretty close to the Washington Monument, three-dimensionally Washington Monument, and then way over here, let's say 1,000 miles away, we have the St. Louis Arch. I've only seen it once, so I know the Washington Monument much better than the Arch. And if we actually took basketballs, a regular-sized basketball, stuck it on top of the Washington Monument, something about 3/4 the size, and stuck it on top of this arch in St. Louis, this distance right here, this distance, which in space represents 4.2 light years. So if we actually are going around the sun, the Earth going around the sun, remember, in a counterclockwise direction, if we sent a message to Alpha Centauri at the speed of light, it would make it there in 4.2 years. If they responded, another 4.2 years, and make it an 8.4 light year, year return. So if you want to say, hey, how's it going? They would get that message in 4.2 light years, and then say, it's going okay here, 4.2 light years back. You can see how distances can actually be pretty far, and those are the closest stars. Okay, let me get rid of these guys, and those guys, and those guys. Okay, so we actually have a nice intergalactic space. We have galaxies, but let's talk about the galaxies themselves. Galaxies are large groups of stars that resemble a solar system. They come in basically 3 different flavors, which we'll talk about later. But what's going on is these stars are circling each other. They're densely packed in the center and they're lightly packed on the outside. And again, there are stars in between. Like if these 2 galaxies are really close to each other, you can see color-wise they're different. You can see shape-wise they're different. This one may be similar to either this one or this one. That one may be similar to those of those, or it may be totally different. But if these 2 galaxies were close together, these would be orbiting around, and they can actually orbit clockwise or counterclockwise depending how you're looking at it. If you actually looked at our solar system from the underneath rather than the top, the way we've drawn it, because we're in the northern hemisphere, you'd actually see the stars going, you'd actually see the planets going in the opposite direction. They go clockwise. So if we're actually looking at the bottom of the galaxy or the top of the galaxy, they could be spinning in different directions. But anyway, that they're spinning, they represent a solar system. The stars go around pretty much in the same direction. If they went around the other way, we may have some problems with gravity and collisions and whatever else, but they go around pretty much in the same direction, except for the stars that are actually outside. These guys are all held by gravity. Gravity is the force, the glue that actually holds these apart. But galaxies themselves can be hundreds of millions of light years apart. Our closest neighboring galaxy, Andromeda Galaxy, which is a galaxy very similar to ours shape-wise, we think it's about twice as large, so it's the largest of the 2, but it's 2.4 million light years away. 2.4 million light years away. So these guys can be tens and hundreds of millions of light years, depending if you're going from this one to that one way over there. But again, these are all galaxies. There are billions of galaxies in the known universe. Some of them are very small. And I'm not saying this one is very small. Probably it's a lot farther away, so it just looks smaller. But let's say these 2 are in the same neighborhood. This one may only have 100 million stars, usually pretty spherical in shape, and we actually call these guys globular clusters. And we do get globular clusters associated with larger galaxies. They seem to be on the outside. Or they may actually be these huge things which contain 100 billion, like the Milky Way, 2 to 300 billion, like the Andromeda Galaxy, and maybe even 400 billion or more in the very largest of galaxies. They do come in 3 flavors. We'll talk about those flavors in a little bit, but no 2 galaxies look alike. Okay, so I'm going to go down to this right here, and I want to show you how we build our own Milky Way galaxy. This is the way we actually imagine our galaxy to look, maybe more like this one right here. But we have, and I'm going to have my kids draw this. In fact, they're going to be watching this, so I want them to draw it. And I want to pick a pen, and I'm going to draw in black on the top. I want you to draw this central thing. That's this thing right here. And this is called the nuclear bulge, or the core of the galaxy. I want you to draw spiraling arms going out. Don't actually have to be as perfect as you see, or they can be easier to draw than what you see here. These are the arms that spin out. I do want you to draw the sun being about 2/3 of the way out. I do want you to draw this halo that goes around. And I want you to draw little dots inside of it. These are the globular clusters. They tend to be more red or orange, which, if you remember about stars, they signify older stars, cooler stars. And then here's another color view, much brighter in the galactic core because the stars are a lot closer. They also tend to be a lot bigger, a lot burning nuclear fuel a lot faster, so they do tend to be brighter. And then we have the bluer area out here. But I'm going to show these kids build your own Milky Way, and this looks like this. This is from Amazing Science. Just type in build your own Milky Way into Google and it'll take you right to it. But here's that view that I wanted them to draw, and if you throw this one in there, you can see that's that central bulge, or the nuclear bulge, and this is where we get a whole lot of older stars to actually be located, but again they're much brighter. Then we have this spiraling arms going out here. This is where you tend to find the bluer stars, the younger stars. And again, our sun is about 2/3 of the way out, like out here. They're going to show it as being right there. We're on what's called the Orion Spur. If you're in the Khan Academy video I'm going to have you guys watch, they'll actually show you a magnified view of that spur, showing you the size. But again, this thing's like 100 to 120,000 light years across. It's a very big grouping of stars. We throw the blue stars, the younger stars. They're showing them as being young or hot stars. The reason that they're blue is because they're burning their fuel very, very, very fast, so they can't get very old. And then in the central bulge, this is where we get the older stars. They're red for the most part. And a supermassive black hole in the center. Okay, the next thing we're going to do is I'm going to assign my kids in class to do this activity. This is what I just basically call the classifying galaxies. And what they're going to do is they're going to look at 15 galaxies. These are negative images. Astronomers like negative images better than positive images. What it does is it makes the dark sky look white, and it makes the bright stars look black. And it's easier to see definition, where you may actually not get to see the definition if we see the positive view. So these are negative viewed stars. And what I want them to do is I want them to come up with a shape for this galaxy, and things like pinwheel. And I'm just going to take that. And then what I would like them to do down here in their categories, they're going to have probably no more than 4. Some actually do have 5 or more. Most of them can get done in 3. But we're going to call like pinwheel. That's going to be the name of the galaxy. And we're going to say this is galaxy 1. And defining characters, can say it has a central area and arms that pinwheel out toward the outside. And they're going to write that right there. Then they're going to go over to galaxy 2, and they're going to say, does galaxy 2 look like that characteristic? And they can say yes. But if they actually said this one looks like it spins in a counterclockwise direction, this one may actually spin again in a counterclockwise direction, except this one isn't, so we'd have to say that's clockwise. So what we did on this one is if they actually did say what direction this one spun, then they want to actually include galaxy number 2, which is what I would put it in here. They may actually say doesn't matter which way it spins. Then they're going to go down to galaxy 3. Galaxy 3 doesn't look like 1 or 2. So we're going to have to make a new characteristic, and I'm just going to call it dot. And that's going to be galaxy 3. And defining characteristics has a central-ish type area, but no spiral arms. Looks like I could probably put galaxy 11 in that group too. And then look for like galaxy 4. I could maybe put that into spiral. I could put that one into the dot. And then we get to galaxy 6, and galaxy 6 doesn't look like it has arms, and it doesn't really have that central blob. So that's going to be my third group, and you can call it whatever you want to call it. I would put that's galaxy 6. And then what defining characteristics. And if you actually can get all these galaxies in those 3 groups, you just keep going. If you can find a galaxy in there that doesn't look like 1, 2, or 3, you're going to have to come up with a galaxy 4. And then if there's a 5, your 5th galactic type, you're going to have this. And then what I want them to do is I want them to go look at Hubble's view. And Hubble's view looks something like this. And he called them EO, which is perfectly spherical, all the way over to E5, which looks more like a cigar. SO sort of looks like this shape, except it's starting to get a fuzzy outside to it. And then we move over here and we have SAs, SBs, and SCs. And then we have SBAs, SBBs, and SBCs. You can see there's a difference between these, and basically what happens is the spiral gets more open as we go towards this end, and it gets more closed as we go this way. And then I want them to go back into this galaxy, and I want them to classify all the what are called the E galaxies, all the S galaxies, all the SB galaxies, and then what are called the irregular galaxies. And I want them to write the numbers, I want them to write defining characteristics, and then I want them to answer these 3 questions. And then they're going to go into this site where I want them to actually go in and summarize Hubble's tuning fork. So they're going to get another view of material for Hubble. All right, thank you much. Bye. And again, that's galaxy 1 of 2.